The notes were the Algebra 1 Unit 7 study guide. The first part of the study guide is simplifying each expression using the law of exponents. In the first question, we have power to power. So 5 to the 4th power, x to the 0 to the 4th power, followed by y to the 6 to the 4th power. Following along with our power to power rules, we would then raise each base to the 4th power. 5 to the 4th, 0 times 4 is 0, x to the 0. 6 times 4 is 24.
6 times 4 is 24.
Therefore, our final answer would be 625 times 1 times y to the 24th. Completely simplified, the answer would be 625 y to the 24th. Example 2, we would multiply the coefficients. 4 times 3 is 12. And now we have product of powers, but we're going to group them based on base. Base is 7, so x to the 7th and x to the 4th. Group based on base y to the negative 4, y to the 8th. Using our product of powers rule, we would then be able to add 7 plus 4 as a base of x, negative 4 plus 8 as a base y. Given the final result, 12 x to the 11th, y to the 4th. Example 3, we can use quotient of powers rule, but our coefficients will be divided. 24 divided by 4 is 6. Grouping together based on variable, we have g to the 9th over g to the 5th. Followed by 1 over 8 to the negative 6. Now recall, we cannot have a negative exponent, so we will need to change that. But because it's in the denominator now, to create a positive exponent, we'll bring h to 6 in the numerator. And then quotient rule allows us to subtract 9 minus 5 for the exponent of g. 9 factors of g in the numerator, 5 factors of g in the denominator. 5 of them will cancel, leaving us just with 4 factors of g and 6 factors of h. Preceding that, we have a coefficient of 6. That is all of the examples for simplifying with laws of exponents. Now we move into simplifying radicals. Looking to simplify square root of 27 down into root 9 and root 3. Root 9 being the greatest perfect square that goes into 27, leaving us with 3 root 3. We could alternatively break down 27 into a factor tree of 3 times 9, all by breaking down 9 into 3 times 3. Circling the pairs to go outside the root, we have a pair of 3's, leaving us with 1 factor of 3 on the inside of the root, leading us to the same result of 3 root 3. Not only do we want to review simplifying square roots with numeric radicands, number inside the root, we also want to simplify with variable terms inside the root. So if we broke down a radical into roots f to the 8th and root g to the 3rd, we would divide the power by 2 because we have square root, which is technically 1/2. So 1/2 of 8 is 4 without a remainder. 1/2 of 3 is 1 because we divide 3 by 2, we get 1, and there's one remaining factor of g on the inside of the root. So g root g. Hence the answer would be f to the 4th power g radical g remaining inside the root. Sometimes we'll have a mixture of numeric radicand, variable radicands at the same time. And separating them out like so. Break down root 40 into 10 times 4. Root 4 is 2. 10 breaks down into 5 and 2, but neither one have a root. So 2 root 10. 3 divided by 2 is 1. So 1x out. 1 left over in. 1 is not divisible by 2. So we leave it as root y. 6 divided by 2 is 3. C to the 3rd. So we will now group together what's on the outside. C to the 3rd, x, and 2, giving us the result of 2xz cubed. On the outside, grouping together inside the radical, we have x, we have y. Next part is determining if the table is linear or exponential. Here we go. Determine if the table shows a linear function or exponential function. Circle 1. Notice adding or subtracting by a constant becomes linear. -9 plus 4 is -5. -5 plus 4 is -1. -1 plus 4 is 3. -3 plus 4 is 7. Therefore, adding a constant each time becomes linear. Either multiplying or dividing by a constant becomes exponential. Let's see why part B's table is considered exponential. 48 divided by 2 is 24. But 24 divided by 2, is that 12? Yes. 12 divided by 2 is 6. And 6 divided by 2 is 3. Therefore, this table is indeed exponential. Example 8 and 9, we want to analyze the exponential equation. Does the equation represent growth or decay? 0.4 is less than 1, so that is considered decay. Whereas in number 9, 3.2 is greater than 1, so that becomes growth. What is the growth or decay factor? In number 8, it's 0.4. In number 9, it's 3.2. Now part C may be challenging to identify the growth rate or that we're finding the rate of growth or decay. We would then identify that by subtracting 0.4 from 1. Hence, the rate would be 0.6. Since the decay rate is 60%. Whereas in the other question, the growth rate would be 3.2 minus 1, which is 2.2. So the growth rate is 220%, which realistically may not happen, but in this case, that's what it would be. Initial value is simply the coefficient of the base, which is in this case 6. In the case of number 9, it's 2. The last part of Unit 7 study guide is being able to graph exponential growth and decay by creating a table of values. Our table of values simply can have the values of x as 0 and 1. To obtain the value of y, we would then do -3 times 2 to the 0 power. Law of exponents states that 2 to the 0 power would be 1. 1 times -3 is -3. Plotting a point at 0, -3 to start our formation of the graph. Next, we have a value of x is 1. So -3 times 1, or times base 2 still, to the first power would be -6. 2 to the first power is 2, times -3 is -6. Plotting the point at 1, -1, 1, then -1, 2, 3, 4, 5, 6. Giving us the graph, such as this one, as the result. In part B, or number 11, we have 3 times 0.5 to the x. 0.5 being less than 1 indicates a degree, not a degree, exponential decay. If x were 0, we'd multiply 3 times 0.5 to the 0 power. 0.5 to the 0 power once again is 1. 1 times 3 is 3. Plotting a point at 0, 3. We then plug in 1 for x. 3 times base 0.5 to the first power. Keep in mind 0.5 is the equivalent of a half to the first power. Half to the first power is half. Half of 3 is 1.5, or 1.5. So the x is 1. We'll move up to 1.5. Keeping in mind we do have a horizontal asymptote where the graph can't become negative. Our graph would then go down, not crossing through 0. This concludes our study guide on units. Please review and be prepared for your upcoming test. Thank you.